Hey guys, welcome back to my channel Amog ICSE Insights. So today we are going to start with metallurgy. I'm not taken so much, so I'm just telling about the extraction of metals, not about aluminium, not about ore, not about the mineral, nothing else. Just extraction of metal, the four main steps. Okay, so let's begin. At first, I'll explain in short, then we will go in detail. So first, the summary. We have four steps in total to extract a metal. Okay, first of all, dressing the ore. Dressing the ore means removing the impurities from the ore and making the ore pure into its pure form. Okay, first of all, the main impurity found in any ore is gangue. So there are four types to separate gang, but mainly the main ones are hydrolytic method, magnetic separation, fourth flotation method, and chemical method is not so much preferred, but it's preferred in aluminium. Okay, let's go ahead. So the impurities are separated by hydrolytic method. I'll explain in detail. Next, okay, magnetic separation, fourth flotation, and next conversion of oxides. Concentrated ore is converted into metal oxide through roasting. So I think you all have read what is roasting in 8th standard. Okay, if who have not read, for them I am informing. Roasting is something that this roasting process requires oxygen to burn something. To burn something, this roasting requires oxygen. But there is another method which is called as calcination, which doesn't require oxygen at all. This can be done in absence of air. Okay, this process remove volatile impurities. Okay, next if we go ahead, reduction of oxides. See, all oxides can't be in there just like. mm what do we call, I don't know that word, you tell me in the comments, it's a question for you. Okay, metal oxides are residue. Okay, that's, don't ignore that, that's my mouse. Metal oxides are reduced to free metals using reducing agents like hydrogen, carbon, or carbon monoxide. For highly reactive metals like sodium and aluminium, electrolysis is employed. So this means that for highly reactive metals, electrolysis is okay. Wait a minute, what happened? Yeah, for highly reactive metals, electrolysis is main, and for least reactive metals, electrolysis is not required. They can be just reduced by adding hydrogen, carbon, or carbon monoxide. Okay, next, if we go with electro refining, this is just for reference, which is given in your book. It's not in the syllabus, but they are given for reference so that you can understand the method in a whole. Okay, impure metals are purified using electrolysis, where the impure metal is the anode and the pure metal deposits at the cathode and impurities form sludge. Okay, as I think you have all read electrolysis in the 5th chapter, or if not, I'll make a video of electrolysis tomorrow. Just inform me in the comment section. Okay, this electrolysis is very simple. Inform me in the comment section. I'll make a video of it tomorrow. So let's move ahead now. Okay, like I'm taking a laser pen so that you all understand it. So here, as you can see, okay, wait, this is a bad idea. I'll change it. Okay, pen is better. Okay, this is a process. Dressing of ore. At first, we'll go with dressing of ore. Oh my God, my bad, my bad, my bad. Yeah, dressing of ore. First, we'll go with dressing of ore. So, as you all know, what is dressing of ore? I have informed just now. To make the ore or to reduce the concentration of the ore by separating its gangue or impure part of it. Okay, this process is essential for preparing the ore by separating impurities or gangue from the ore before further processing. See, this ensures the better yield of the ore and efficiency during subsequent steps. So, when we separate the impure properties, the only pure form come out. This pure form, as you all know, pure form is better than impure form. So, this makes the yield or the yield of the ore better than impure form, and its efficiency also increases. Okay, methods of dressing. There are four methods of dressing. but I have mentioned only three because the fourth one is not so important. It's just a simple method. I'll explain it by mouth, but these three are important. First method is hydrolytic method. Okay, this uses water to separate heavier ore particles from lighter impurities. As you all know, ore is heavier than impurities always. That's the truth. Okay, so works effectively for ores of minerals like hematite and cassiterite. What is hematite? I think you all know hematite is the ore of iron oxide and its formula is Fe2O3, and cassit. One minute, one minute, guys. Give me a second. And cassiterite. So this works for this both. In this, what they do, they make a a slide, and through which they first like they first put the ore and then they'll pour water in it or make a water channel. This what does it does, this water channel makes the heavier particles settle in the parts called grooves, and the lighter ones they flow away with the water. The lighter particles flow away with the water, the heavier particles settle in the parts called grooves. This makes it very easy to separate the impure particles. So next, if we go with magnetic separation, in magnetic separation, as you all know, some ores are magnetic like iron ores and steel. Steel is okay, steel is iron, sorry, my bad. Iron ores and not so many other ores except iron, no. And hematite, magnetite, iron pyrites, sapphire iron ore, which is iron carbonate, these all are attracted to magnets. So when they'll make what do we call that, which flows, my bad, guys. One minute, guys, my net is not stable. I'll just stabilize my net, guys. 1 minute, give me a second. Yeah. So, as you all know, there's a pathway which flows continuous, and we call it as a conveyor belt. And they make the ores flow on the conveyor belt, or they put the ores on the conveyor belt, and below the conveyor belt there will be a magnet which separates the magnetic ores, and the impure gang or something fall apart, then the ores, and ores are separated which are magnetic in a pure form. But this sometimes there will be impure metallic which attracts the gang. So what do they do, when the ore is not a magnetic ore, like not a iron or some other magnetic ore, so then the gang will be magnetic obviously. So they separate the gang with magnet, and the pure part which is not the iron ore or some other ore, that falls apart. Non-magnetic ore falls apart and the magnetic gang falls into the gang part, magnetic part. So this also separates them. So it's vice versa. When the gang is non-magnetic, ore is magnetic. So ore is separated by magnetic properties. But when the ore is non-magnetic, gang is magnetic. So gang is separated by magnet. Okay. Remember this both. This is a vice versa, and this is very easy. So there may be a compulsory question on this one on the 2026 paper. Once the specimen papers are released, we'll even solve them. Okay. Next, we'll go with fourth flotation method. In this method, what they do is they first take a big beaker. In that they pour water, and above water they pour a small layer of oil. Okay, not so small, they'll like a layer of oil. And what oil does is it doesn't mix with water, as you all know. So the gang separates and falls down into the water, but the ore floats above the oil. This makes it easy to separate the gang and the ore. And this is very easy. This question may come in the MCQs, so be prepared for it. Okay. See, as I written here, utilized mainly for sulfide ores. This is for sulfide ores, as sulfide ores are very like they are what do you call those? They are very non-magnetic and they are not so heavy. So this method is used for them. And next, if we go, ore is powered and mixed with water and oil and chemicals. Air is blown in, creating froth. Metal containing particles stick to the froth and are skimmed off for further treatment. See, when there is metal containing particles, this skim or stick to the fourth and are skimmed, means they are removed, that stick to the oil part and they float above and the gang settles down. Okay, let's move on. It's already uh, going ahead. Like next, conversion from concentrated ore to its oxides. So as you all know, this step transforms the concentrated ore into a more reactive oxide form, which is easier to reduce. See, as you all know, metals are reducing agents, non-metals are oxidizing agents, and metallic oxides are basic, so they are more easy to be reduced. Okay, basic oxides are more easily reduced than acidic oxides, which are non-metallic oxides. Okay, so this involves two processes. There are two types of conversion into oxides. First is roasting and another is calcination. As you all know, roasting is where the process, in this process oxygen is used, but in calcination no oxygen is used. Okay, ore is heated in excess oxygen, removing volatile impurities commonly used for sulfide ores like zinc sulfide. Example is 2ZnS plus 3O2. I think you all know this equation. Copy down this equation. This is a very important equation. This equation was asked in the paper of 2017 or 18. I don't remember, but it was asked. Okay, here, in the presence of oxygen, the ore is heated and converted into its oxide. Next, the temperature must be controlled. There should be a controlled temperature, not overheated or not underheated. A normal, moderate temperature should be given here. And the key byproduct, which is the sulfur dioxide, can be collected for industrial use. This sulfur dioxide can be collected for industrial use only. Okay. Next, if we go ahead with calcination, there is no air in calcination, and this is like very easy. Just heat the uh, compound and it will separate into two parts. Like here we are heating calcium carbonate and it is being separated into calcium oxide and carbon dioxide. Okay, removes moisture. This mainly removes moisture and volatile impurities from the ores like limestone or hydrated minerals. Okay, let's move ahead. Now, if we move ahead, reduction of metallic oxides to its metals. See, I said you, basic oxides are easy to be reduced than acidic oxides. So here, metallic oxides, which are basic, are being reduced into metals. The oxygen is being removed. So mainly we reduce by adding carbon, hydrogen as their main reducing agents. Carbon monoxide, hydrogen, and carbon are the main reducing agents of all these. Okay. So if we move ahead, reduction converts metal oxides into a free metal. Means like if you take aluminum oxide, that is converted into already, like that's converted into metal. Okay, the method depends on the reactivity of the metal. So here comes in the electroactivity series, which is I will give you a short form for it. Wait, let me remove a pen. There's a simple short form for it. K, I'll write it down. Na Ca Mg. Don't mind my handwriting. I'm writing with a mouse. Okay. Al Zn Fe Sn Pb. My bad, guys. My bad. Please understand. H Cu Hg Ag. I think you guys are understanding what I'm writing. So it's potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, which is not a metal nor a non-metal. So it's given a position in the bracket in the middle of it. Then copper, uh, Hg, yeah, mercury, and Ag, which is silver. Okay, and I think you all guys know that copper silver is the least reactive and potassium is the highest reactive. So let's get into the topic back. So first we are going to reduce metals like copper. Okay, copper comes under hydrogen, so this can be easily displaced by even the metals above copper, which are potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. So here I have taken CuO plus H2. So this is easy to separate that thing from separate oxygen from copper. Okay, here we are reducing copper oxide into copper and water. See, CuO plus H2 gives rise to Cu plus H2O. See, copper plus water. Hydrogen reacts as a reducing agent here. As you all know, hydrogen is the best reducing agent than any other metal. And next, reduction by carbon. If we see that carbon is also a reducing agent and it's like hydrogen itself, but when you take carbon for just carbon for reducing, you have to take metals of which have valency more than 2, because it forms carbon monoxide, which is very dangerous and very harmful during reduction of metals like lead. So this, see, lead oxide plus carbon gives rise to lead plus carbon monoxide, and you all know carbon monoxide is very dangerous metal. So just don't try this in labs, it's very dangerous for you. Utilizes coke or charcoal in the blast furnace. Okay, this uses mainly coke, not charcoal, but charcoal sometimes when coke is not given or not there. Reduction by carbon monoxide applied to iron oxide. Okay, so what here is, as you all can see, oh wait a minute, I went ahead, my bad guys. Yeah, it's here. Um, yeah, as you all can see, reaction is like Fe2O3. So there was no subscript in PowerPoint. I had written like this: Fe2O3 plus 3CO gives rise to 2Fe plus 3CO2. So here they have taken carbon monoxide, which is very easy, and it's very like you guys can tell, it's not so dangerous as it forms carbon dioxide, but during addition of reactant you have to be very careful. This is mainly done in the presence, so carbon monoxide is generated from coke and reacts with iron oxide to produce iron, and this process mainly takes place in the presence of oxygen. So it is done during roasting. And electrolysis of active metals. See, active metals are electrolyzed highly, and here I have written it for you: potassium, sodium, and calcium as the most active metals, and they are electrolyzed, not reduced by adding COC or H. They are electrolyzed in the form process of electrolysis, which is very safer compared to all these. And no other, like you can take for example, if you take calcium, that can be replaced by sodium or potassium. But if you take sodium, only potassium, and if you take potassium, no other thing can replace potassium, as the potassium is the highest element. So if we move ahead, this is our last topic for today: electro refining. It's not in the syllabus, so I'll just let you read this, you understand it. Just I'll read the topics and I'll explain in short. Electro refining purifies impure metal obtained after reduction. See, sometimes even the metal which is obtained after reduction is very impure, and this helps in reduction of the impure metal. Uh, this helps the conversion of impure metal or purifies the impure metal after reduction. Means like you have seen reduction here. After this process, it's converted into pure by electro refining. It's not in your syllabus, but I'm even the for your reference I'm telling it. This procedure is very simple. An impure metal is made at anode, pure metal at cathode, and the electrolyte consists of a solution of metal salt. Metal salt may be like you can take NaCl or CaCl, MgCl. Okay. Oh, next, during electrolysis, metal ions. Okay, okay. No. So yeah, that's it for today, guys. Meet you in the next video. Remaining all you can read ahead, and I'll hold it for 10 seconds more. Thank you. Like, share, subscribe, share to your friends. Let them learn. Happy learning. Hustle hard. Bye bye.